So I'm here today to talk to you, hopefully give you a little glimpse into what chaos engineering looks like internally at Google, how long we've been doing it, what kinds of things we do, and maybe give you some tips for getting started yourself. I'm Jason Cahoon, site reliability engineer at Google, and I've been working on Google's DiRT program, which we'll talk about in a second. I'll explain what that is, since 2016. Nowadays, I am mostly doing software engineering for internal tools related to incident management. And also, I maintain a library at Google that's used for RPC fault injection, which is a particular variety of chaos engineering. And I'll talk about that a little bit too. The Google DiRT program. This stands for Disaster Resiliency Testing. And Google's been doing this since 2006. So we've got 15 years of experience in what now is more commonly being called chaos engineering. And we started this to intentionally disrupt services, especially those that were hosted out of Mountain View. Because, you know, as most people are probably familiar, Google basically grew up out of Mountain View, California. And despite having a global presence, there was a lot more things being hosted and served and created in Mountain View. And some engineers noticed this and realized that this was a bit of a risk. Like maybe we're singly homing things, maybe other systems that are meant to have backups, like we might not actually know that those backups work, that those alternate routes for serving things are behaving the way we anticipate if Mountain View becomes unavailable for whatever reason. So it started out very much being about, you know, what if this service goes down that's hosted in a particular area? Are we globally covered? But it pretty quickly grew to be encouraged company-wide. So we don't just test technology systems. We test emergency responses. We test procedures, people, business continuity plans, even things down to building maintenance. Everything is fair game, and we encourage all aspects of the business to come up with test plans so that they can be reviewed and potentially run as part of our annual DiRT events. So why did Google start doing this? The idea is we want to discover problems in controlled circumstances before they come up naturally on their own. So our motto within SRE is hope is not a strategy. And the idea here is that if you don't test your system is going to test you. Eventually the universe is going to come around and problems will happen. And unless you have some muscle memory for how to deal with that, or that kind of effort put into deeply understanding your system when it's not operating at its best, you won't be able to interpret what's going on. You won't be able to have as immediately at hand the information about, oh, when this goes wrong, this is what happens. When that goes wrong, this is what happens. So it allows you to reason about your system much more deeply when you've seen it misbehave, or you've seen what the ramifications of certain dependencies being unavailable, for example, are. We've been measuring this as the program has gone on. There's actually a pretty formal process involved in the planning, review, and then analysis after the fact of all of the experiments that we do, and have found that this building up of the muscle memory practically reduces mean time to mitigation for real incidents. And so teams that participate more heavily in DiRT exercises have shorter incidents. So I said before that, you know, everything is fair game. So the most immediate thing most people think about with chaos engineering is software systems, maybe infrastructure like networking. But we encourage taking it to the next level, and really, like, any part of your business can potentially stop working at any time, and you want to know what happens when you pull that piece of the equation out. So this can be facilities, Communications from your headquarters or remote offices could be disrupted. Data centers come online, offline, power issues different places, software misbehaving, latency being there, bugs being there. You can lose access to systems accidentally. Your access control systems can become disrupted. Your deployment pipelines can get gunked up. People can be unavailable. Maybe the expert in the system is on vacation that week, or hiking in the Himalayas and not available. And then just generally, are your teams prepared to deal with incidents when they happen? These are all things that are going to make and break your reliability. So we have a number of pre-canned themes that we push people towards when testing these areas. And this is, some of the things that I was just talking about, like, you've got potential failover paths that if you don't execute them, like, you can't really be sure that they work. Your workarounds and tools, documentation for given high-level incidents and emergencies, you need to make sure that stuff is in place. You need to make sure that your rollback systems for if you push a bad binary, that those are working the way that you anticipate. You need to know how long it takes to roll back a system. Run at service levels. That's a very interesting one there. And this kind of gets into the fault injection stuff that I had mentioned I work on before. So at Google, we have some libraries that allow us to intentionally disrupt communication between any two binaries. So we call this RPC fault injection. And what we can do is say that, between this application A and application B on some given service, I want to inject X milliseconds of latency, or just completely subvert the request with an error that I choose. And this allows us to pick and choose dependencies, even potentially deeply nested within the graph of all dependencies that an application has, and test what some front end looks like or behaves like in the absence of those dependencies, or under conditions where they're essentially operating at their published service level. So frequently, what we see happening is that a given service in the deep in the back end might be really, really, really reliable on average, although it was engineered with much looser tolerances. So publicly, the statement is that our service level might be, we're going to respond within 1 second to all requests. But on average, you might have like a 50 millisecond response time, a really, really, really fast response time. And what you find happens is that over time, this is that drifting towards failure that Courtney mentioned. People that build systems depending on this backend will just assume that 50 milliseconds is what they're going to get all the time, no matter what, forever. And there are extreme conditions where that 1 second response time will just pop up. It may be years in between those conditions happening, but they can happen, and we know they exist. So downstream consumers need to be aware of them as well. So what we'll do is we'll run that service at its SLO, at its service level objective, to make consumers aware that this is something that they have to deal with. And one of the most famous examples of this that we've talked about publicly in other talks in the SRE book is our global lock service, which is called Chubby. And Chubby has a certain error budget, and any excess in the error budget that isn't consumed by naturally occurring or organic emergencies, every quarter was actually just burned by taking the service down until it was literally at its SLO every quarter. And what this did was prevent consumers of this global lock service from assuming that it's always available, because the reality is it's not. So when you get started with testing, it can be quite appealing to do theoretical tests first. So this would be what we call at Google like Wheel of Misfortune, where you come up with essentially like a role-playing game where a disaster or emergency situation is presented to an individual that might be an on-caller or a group of people, a whole team, and there's some person that plays the game master, and they walk the team through the scenario, and the team decides like how they're going to respond to things. And this is great. This is a good way to start to build some experience, but we really encourage within Google that we try to make tests as realistic as possible. And if you inject real failures or turn off real systems and perform experiments in an actual real environment, even if it's a lower environment like dev or staging, you're going to get measurable results that will help you not only confirm that the things that you're going to do to respond to that incident are accurate, correct, helpful, but they also show you how that system responds in the given scenario. So the final point here is establish an expectation of what your service level is, so that you can have a budget, sort of like the chubby test that I just mentioned a second ago, that allows you to burn your error budget on disaster testing afterwards. And this is an approach at Google that I think has been really helpful in creating room for performing these kinds of tests and informing, when is enough enough. So if I come up with a test and I have a prescribed amount of error budget that I'm willing to spend on it, if it starts going off the rails, I know I can hit the big red button and tap out of that test very quickly, because I've hit my limit, the threshold of how much I intended to disrupt this system. And I know that I may be approaching going way beyond what I intended. How do we choose what to test? So we tend to let the engineers go wild and come up with what they think the least well understood aspects of a system are, the riskiest areas, and we also use real incidents. So engineers are pretty good at having a critical mind and understanding what parts of their system are less great than others, or which parts are probably more likely to be confusing or fall over. And so if you field responses on what to test, like most likely the people that are very familiar with your systems are going to have plenty of suggestions of like what keeps them up at night. Real incidents, on the other hand, you already know those are potentially problems, and you've probably done some work to fix those, but the question at that point becomes, how do you know that the things that you've done have actually fixed the problem? And what we try to do to prove that is rerun a similar but contained incident from that essentially looks like the original one, to show that whatever mitigations have been put in place are actually effective. At Google, we have a standardized test plan and review process. So this ask all the engineers to come up with things is literally what we do. And we get thousands of submissions a year. And these are all reviewed, and there's a back and forth, sort of like a code review in a way, except this is just over a plan document. And we have a team of DiRT alumni that look at this and say, all right, we need more information here. We need a level of detail that someone that has no idea what this test is about, or what the nitty-gritty details of this system are, would be able to execute both the initiation of this test and the rollback. So covering what do you do when things are not going as you expected, and potentially getting too risky, like how do you roll the system back, is a very important piece of what you'd like to cover in your test plan. And then after every DiRT test, we do what we call a mini post-mortem, where there's an analysis phase of what what we saw happen, and what kind of action items we can pull out of that. So once you decide what to test, you want to establish what you're going to measure. You want to know where you're going to be collecting data from. We evaluate the test based on, does this test actually add value, or is it just, pointing out something that's really obviously already known to be broken or a risk? Because if you've got something that's really, really, really obviously broken, that you already know exactly what's going to happen when you disrupt this system, arguably it's not worth testing until you've already fixed that problem. So you should probably spend the time to try to mitigate that system preemptively and then run the test to show that your mitigation was actually effective. Again, if there have been any recent significant incidents or any really heavily relied on dependencies within your organization, like maybe some service that practically everything talks to, those are good candidates for inspiration about, like, maybe I should be looking at what happens when this system behaves less than optimally, or maybe I want to know what's going to occur if a similar incident were to pop up again. So at Google, like I said, we're probably in the approaching like the tens of thousands of tests per year. And with the current growth rate at Google, most of the people that I interact with that are doing this kind of testing are doing it for the first time. So despite that Google has been doing disaster testing for 15 years, the vast majority of people doing it year over year are doing it for the first time and are relatively new to Google as well. So I would give you the same advice that I give most of the people that are showing up and asking me quite literally, like, how do I get started doing this? Establish rules, get some buy-in from other people on your team or your manager, communicate about what you're going to do broadly and often, make data-driven decisions about what to test. Don't just do it capriciously. Once you monitor your test, you find problems, fix them, follow up by repeating the test. Report on the results, again, communicating those broadly. And once you go through this cycle a few times, you want to look at automating and providing repeatable tests through automation that can be part of your CI/CD pipeline. And just rinse and repeat. Pick another testing subject, move to another area. This is why at Google we have some tests that are come up basically every year, and after a certain amount of time we'll automate those, and then some variant will be running quarterly and eventually monthly, and then eventually on demand by teams that could potentially be impacted by these tests. One thing that people frequently bring up and worry about is like the difference between testing production and testing in production. I probably dozens of times had people bring up the point of like, isn't this testing in production? And I want to reiterate that this isn't a replacement for your standard unit integration and functional testing. This is something that should be an enhancement to them, something that adds on to functional testing. So you might have a normal suite of functional tests, but also want to repeat those by overlaying certain failures on top of them. For example, what happens when this given dependency is slow? What happens when this dependency is completely unavailable? And we're seeing a movement at Google with more integration of tooling that allows users to perform these kinds of fault injections even within hermetic integration testing setups. Ultimately, you have to test your production infrastructure and environment, and that's different from testing your software in production. The environment will be more complex in production. The reality is always more complex than your simplified model that you'll have in your development and staging environments, and you're proving the environment itself, not necessarily the software that runs within it at that point. And And you really shouldn't have confidence in any behavior, fail-safe, or workaround that you haven't actually exercised and seen work repeatedly. Anything else is just wishful thinking. So set clear goals for what you're going to do when you write your test. Build confidence by incrementally increasing the blast radius. So we might start with 1% of traffic being fault injected, increasing it to 5%, increasing it on and on and on after a few hours. And this gives you the ability to look at the metric that you're monitoring while the test is going on and see if you've hit your threshold, that error budget that we talked about earlier. So as you're ramping up, if your error budget is burning a lot faster than you anticipated, then you're already getting results for your test. It could be worth stopping the test, rolling back the test, and evaluating why the error budget was burning at a rate much higher than what you initially anticipated. I'd recommend, initially writing tests that are focused on customer experience. There's so many things that you can possibly test that zeroing in on things that will actually make a difference for your customers in terms of the reliability that they experience will help the bottom line of your company. It's critical to ensure that rollbacks that you are quick and reliable, and essentially you need a big red button system that you can reliably say, all right, test is over, and know that it's over. There's all sorts of reasons why you might need to stop a test. Sometimes it's the test itself. Sometimes it's just a coincident thing occurring that you have no control over. Maybe a real incident happens at just precisely the same time that you were running some long-running test. You need a way to say, all right, I'm calling the thing off for now, at the very least. Generally, you want to let people know that you're testing. Sometimes, and once you're a little bit more advanced, there can be benefits to testing the on-call rotation or practical on-callers themselves, in which case you might not tell them ahead of time that you're performing a test, but when your fake alert or fake problem shows up, you would definitely tell them that this is part of a DiRT test or a disaster test, chaos engineering test, so that they know that if a separate real incident were to come up, that the real incident should be taking priority over this test of the on-caller or test of some on-call procedure. After your test, you want to dive into the analysis as well as you can. Google has a blameless culture with finding problems in this regard. So don't be focused on individuals as much as processes, procedures. Those are the things that can be fixed. Individuals, you can swap people in and out, and they're likely to make the same mistakes in a poorly defined system. Focus on what worked, but also what can be improved. Actually collect your action items, put them in your bug tracking system, and don't ignore them after that. We track metrics on bugs that were generated from disaster tests within Google and treat them somewhat differently and have a different response SLO for these bugs. So we have service level obligations for our bugs, and for DiRT tests, essentially if you leave them hanging for too long, then you're going to have upper management start pinging you about, why isn't this addressed yet? Sort of in the same way that if you have a post-mortem analysis after a real incident, those action items are probably going to get a little bit more attention. We treat DiRT-generated bugs much the same way. So what has Google learned from all of this? The failures are inevitable. The best you can do is try to be prepared for them. And if they're going to happen, it's probably better to try and instigate them to happen ahead of time in a way that you have more control over. Surprises are not your friend. And continuous simulation and testing. So any procedure that you have or backup plan you have of, all right, this is what to do in an emergency, this is how the system's going to fail over, or switch over. Anything that you haven't seen work, dozens of times potentially, is a risk. It may not work. This is where some of our compliance auditing actually requires this kind of testing. So one of the objections to performing chaos engineering tests in the production system I've heard before is, oh, this isn't good for compliance reasons, when quite to the opposite. It seems that compliance auditors really appreciate these tests more than anything else. We test everything. There's no distinction between some business continuity plan and a disaster recovery plan. So we're talking people and technology. We are doing things even like management, chain of command management. You can have situations where someone needs to approve purchase in an emergency situation, and maybe someone's unavailable. So is your chain of command, like, do you have a backup plan for every aspect of your business? And repetition being really, really, really important. So just once is not enough. You've got to do this kind of stuff continually to show that you're not slipping and not drifting towards failure over time. These complex systems are changing, they're dynamic. The demands we put on them are dynamic. Every piece of software in your technology stack is changing with every push that you do to production, and they're going to change incrementally and boil the frog slowly over time until all of a sudden a failure sneaks up on you. So I've just got a couple of examples of the style of tests that we do at Google. I thought it would be good to give you a few practical examples here. So this is this failure injection test that I was talking about with run at service level. And you might have a scenario where an unusually large traffic spike degrades the mean latency of a heavily shared internal service, and that service remains barely within its published SLA for an extended period. This highlights to me that there's actually a couple ways at Google that we might approach this test. You can do it at the macro level and the micro level. So you might have a situation that is similar to what I was talking about with our global lock service, Chubby, where globally they burn some of their SLO to create an understanding of what that SLO is among their consumers. And so that's a global service level disruption. We might also approach this from the client side. So at the same time, aside from this big event kind of DiRT test, we might provide libraries that let individual consumers apply the same sort of latency or the same sort of fault injection, disrupting their communication with Chubby from the client side, and let them run a test that only tests their services individually. And these kinds of things work hand in hand. So the announcement of the large global service level test will inspire clients to go test their service individually to make sure that they're prepared for it. And teams might approach it that way. Another example is toggle the ON-OFF discriminator, which in so many words means turn everything off and on. It's kind of surprising to me how easily we can introduce cycles into dependencies of our system within our wider systems. And you tend to not know about these until you actually have to turn things off and on. So if you don't understand the ordering dependencies that exist within bootstrapping your technology stack, they will likely bite you at some point. Unless, of course, you just somehow manage to keep everything on all the time. So this one can have a lot of surprises in there. And sometimes just suggesting this sort of behavior will bring people out of the woodwork that will tell you exactly why you shouldn't do it, which will give you the opportunity to address those problems without actually running the test. But in general, this can be done again at the macro or micro level. So some hierarchy of applications that might be owned by one particular team, they might try to do this at that level, or you could do it, everything going all the way up to an entire data center. Run without dependencies. This is another variant of a fault injection test. So instead of a service running at its SLO, you might want to verify that things that you think are soft dependencies are actually soft dependencies. So are your graceful failure modes actually graceful, or does your application just topple over as soon as the logo or the left pad becomes unavailable? These systems, again, experience drift, and things that start out as soft dependencies have this nasty habit of not remaining soft dependencies. So going through every single one of the external systems that your application communicates with, every RPC that it makes, and proving that it's a critical dependency or not, is a very rewarding thing to do. And again, we're kind of harping on the same points here. When you have a real outage at some point in the future, it's pretty damaging to find out that what you thought was a soft dependency is actually a critical dependency as a surprise during an emergency. So do yourself a favor, try to highlight that kind of information, do some experiments to find that information ahead of time. And then just as a last example.
Sorry to interrupt you.
Yeah.
We have run out of time. So if you could quickly wrap up, and then we can land the talk so that we make room for another keynote.
Yep, this is the last slide here anyways. So I'll just wrap this one up, and this one speaks for itself of, what are your procedures for something like having to replace everybody's laptop within your company? And this is just meant to highlight that, you want to think outside the box. You want to test more than just your software, more than just your infrastructure. All that stuff is immediately at hand, but it can really be anything. So yeah, I think these slides will be available if you want to look at these, or come talk to me. Maybe I can give you more details about how we do things at Google and how you can get started. But yeah, that's pretty much the talk.